Hello, it's Rolly here. In this series I will explain how to make fully working von Neumann 8-bit CPU in Logisim. Firstly, 2 or 3 episodes will be dedicated for Arithmetic Logic Unit, aka ALU implementation, and in today's episode we will try to implement 10 out of 20 ALU operations. My Z-ring value will be 215. You are able to change it as you like. To get started, first of all we need to make a table of our operations so that it would be easier for us to create a scheme. As you can see, I have 20 different commands for our ALU. On the right column I also have operation codes. We'll use them to call the operation. These codes must be different from each other or else it won't work. Also, our ALU will have one single addressing mode. 1 byte or 8 bits will be for operation code, and 1 byte will store registers RD and RS. Also, the ALU will have 3 different flags. ZF means zero flag, BAF bad argument flag, BOF bad operation flag. Now let's start by creating new scheme. Let's name it VLD. This scheme will validate if our input is less than our ring value. Flags won't be implemented for this operation, and our output Z will hold 0 or 1. 1 if it's valid number in our ring, and 0 if it's outside our ring. Next up is neg, and the logic of this is simple. We just need to subtract our input from the ring value, and this command will use ZF and BAF flags, which are implemented by using comparators. To save up some time, I have made dec for decrement, CMPZ for compare with 0, CHL shift left, CHR shift right, roll rotate left, roll rotate right, and inverse, CHL and CHR roll and roar have the same schematic apart from the shifter function, which you can choose from the menu. CMPZ compares the input with 0. A short documentation above every operation will be on the screen, so you can check it out anytime. Inverse operation is a little bit tricky. I used ROM for the inverse values of my ring. To calculate the values I used Excel, and as you can see in the first column I have my ring value, in the second all my ring numbers from 0 to 214, and in the last column I have the inverse. I simply use this formula. Since this formula gives us decimal numbers, we need to convert all of them to hex, so we'll simply use this formula. And now open your text editor and copy all hex numbers, delete last enter, and you may notice that Excel thrown an error in a couple of lines. This means that the inverse does not exist for the particular number, so just simply mark all the NAs and change them to zeros, and the last step is to insert this line into the beginning of the file and save it as EMG file and import to ROM, and now you have your inverse calculations. So that's it for this episode, and I hope this will be helpful, and see you next time.